This is AS1, Physics 1, and it is resistor networks. Past paper questions from between 2004 and 2009. So this first question is from January 2000. Figure 6.1 shows a network of 9 identical resistors. Each resistor has a resistance of 6 ohms. The maximum safe current of a single resistor is 0.3. Through a single resistor is 0.3 amps. So the first thing I'm going to do is write in the resistance of 6 ohms on each one. And the first question asks us to find the total resistance of the network between the terminals X and Y. And so between X and Y there you can see you've got 3 parallel lines, and on each line, if you add up the resistors in series with each other, you've got 18 ohms in each one. So really what you're doing is finding the resistance in parallel of 3 18 ohm resistors. And so if you just use your wee shortcut, you know that if you have 2 identical resistors, you divide one of them by 2 and that's your total resistance. In this case we've got 3, so it's just 18 divided by 3, which gives you 6 ohms. We'll also do it properly just in case you prefer to do that. And so that's 1 over the total resistance is equal to 1 over 18 plus 1 over 18 plus 1 over 18. That gives you 3/18. And to get the final answer, you do of course have to turn it upside down. And therefore the total resistance is 18 over 3. And no surprise, it gives you an answer of 6 ohms. So do it one way or the other, whichever way you prefer to do. The question then asks you to find the maximum safe current between X and Y. And so you know that for each resistor, the maximum safe current is 0.3 amps. So that means in each line, you can have 0.3 amps. So you can have up to 0.3 amps in each line, and therefore going into your circuit, you must have 0.3 plus 0.3 plus 0.3, which is 0.9 amps. So the answer to that is the total current is 0.3 plus 0.3 plus 0.3, which gives you 0.9 amps. Okay, part B of the question. Figure 6.2 shows another network of resistors. You've got no value on X, but you know that this one is 2, this one is 4, and this one is 6. It does tell you down below that the maximum or the total resistance between terminals P and Q is 4 ohms. Show that the resistor of resistor X is 6 ohms. So really what you have there is one single X resistor plus 3 in series with each other. And that's X, 2, 4 and 6. So that's really equivalent to X. And if you add those 3 up, 2 and 4 and 6 gives you 12. So it's an X ohm resistor plus a 12 ohm resistor in parallel. And if you just do it your normal way, I'll just do it with the fractions. So 1 over the total resistance is 1 over X, which we don't know, plus 1 over 12. The total resistance is 4, so 1 over 4 is equal to 1 over X plus 1 over 12. So a quarter take away a 12th is 1 over X. The common denominator there is going to be 12, so therefore 3/12 take away 1/12 gives you 2/12, and that's equal to 1 over X. But of course you have to turn it upside down to get your answer, and therefore X is 12 over 2 or 6 ohms. The resistance between other pairs of terminals may be determined. Between which pair of terminals is the minimum resistance obtained? Now, whenever you have got resistors in parallel with each other, the total resistance is always less than the one of the smallest resistance in any one parallel line. And so we know that this X resistor has got a resistance of 6 ohms. So if you took between there and there, you've got 6, and you would have 2 and 4, you've got 12. So your minimum resistance has to be less than 6 ohms. If you took between here and here, you've 6 here, and you've 6 and 2 and 4 again, you've 12. So you would have a similar value. If you took between here and here, you've got 4 here, and you've got 6 and 6 is 12 and 2 is 14. So your maximum or your minimum resistance is going to be less than 4. So that's the best option so far. if you took between here and here, you have got a 2 and you've got 12 plus 4 is 16, but your minimum resistance is going to be less than 2. And so there's your answer there between P and S, because you've got the smallest resistor on its own in parallel with the rest. Calculate this minimum resistance. So what we're going to do, I'm just going to redraw the circuit here, and I'm going to redraw it with the 2 on the top line. And then on the bottom line, I've got the other resistors. So you've got a 4 ohm, a 6 ohm, and a 6 ohm. So that's between S and P there. So if you just look back at that a wee second, I'll write the 4, the 6 and the 6 in there. Just look back a second. So there's the 2, and there's the 4, the 6 and the 6. And so when you add those up, you're going to have, it's equivalent to a 2 ohm resistor and a 16 ohm resistor. And you can do it using the product of the sum or do it with the fractions. I'll just do it with the fractions here again. So the total resistance, one of the total resistance is a half plus a 16th. And if you change that into sixteenths, you'll get 8 sixteenths plus 1 16th, which is 9 sixteenths. And then you have to turn it upside down to get your answer. RT is equal to 16 over 9. And you can see 16 over 9 is less than 2, and that's what we expected. We expect an answer of less than 2 ohms. You can go ahead then and calculate that as a fraction if you want. Right, it now tells you that an additional resistor of 12 ohms is connected between terminals P and Q. So I'll just put the two things together here a wee second so you can see them. So an additional resistor of 12 ohms is connected between terminals P and R. Calculate the total resistance between terminals R and S. So I'm going to put in my resistor here, and it's going to go in on the diagonal between P and R. And I'm trying to calculate the total resistance between R and S here. Okay, so you have to work out what you think is going on there. And if you have a wee look at that, sorry, I should also put in its value. It's 12 ohms. If you have a wee think about what's happening and draw it the way that you understand that it's happening, what really you have, first of all, between an R and S here, you've got your 4 ohm resistor, first of all, on the top line. Okay, that's your 4 ohm resistor. And then whenever you go round from R, you can see that these two are on a line beside each other. Okay, and so you can put them on a line beside each other, but then that this is in parallel with them, and the 2 is on its own. So when you get round, say you were taking current from R here, you would have a place where the current could go through there, or it could go through here. Okay, so it's going to go right through here and join back together here. So we've got a parallel bit of the circuit here, and we've got a 12, and we've got a 6 and a 6 beside each other. I'm just drawing that like that, okay? And they rejoin again. Okay, so there's my current going from here round through the 6 and the 6, meeting at P, and it has split up here. Some of it goes through the 12, so it meets at P again. So really that is P, this point P. But then we have another resistor to get through before we get to S. We have another resistor to get through, and it's got a resistance of 2 ohms. Okay, and so I'm going to redraw that again so it just looks a wee bit easier again. And if I redraw that again, really what I've got is my 4 ohm resistor in the top, my 12 ohm here, my 2 6s here, and then the 2 beside it. Now, to me, that looks far easier to calculate. I see that far easier than I do see this. I can see that these are in parallel with each other, but then they're in series with the 2 ohm resistor, and the whole thing's in parallel with the 4. These are 6s, and that's a 2. So now I'm going to do my calculations, and I'm going to do the wee parallel bit first on its own. So that gives me a total resistance. this wee bit here gives me a total resistance of 1 over 12 is this line, and this line's 1 over 12. And without doing any calculations, I know my answer's half of 12 there. And so I'm just going to write down RT equals 6 ohms. Okay? So now I've got a 6 ohm resistor beside a 2 ohm resistor, and that means 6 and 2 gives me 8. So I can redraw my circuit again in a way that makes sense to me. I've got a 4 and I've got a 6 and a 2, and so therefore that's 8. So really I'm down to a 4 ohm resistor and an 8 ohm resistor, like that. And so again, I'm just going to do my wee sum. 1 over RT equals a quarter plus an eighth. Changing it into eighths, I've got 3/8. And then turning it upside down, okay, turning it upside down then, I've got 8 over 3. Ohms.